Okay, so in the prior slide deck, we gave motivations, concepts, and API documentation with linked lists, but we didn't see any source code. So with this slide deck, I'd like to take the time to actually do some examples, do some Java examples using linked lists. So a quick overview of what I'd like to do, just a quick introduction, and then how do we add elements to a linked list? How do we remove elements from a linked list? How do we get an element from a linked list? How do we retrieve and remove elements in a linked list? And how do we pop and push elements onto a stack using a linked list as the underlying data structure? Okay, so in this lecture, we'll see different kinds of linked list example programs in Java. If you have any doubt related to the basics of linked lists, well, then refer to the prior set of slides just to shore up your knowledge so you kind of understand conceptually what makes a linked list different from an array list. It's just another way of modeling a collection of objects, though, and they both have their advantages. So how do we add an element to a linked list? Well, let's take an example program where we'll add elements in different ways. We'll use the add. We'll use the add with the index and the object. We'll use the add first. We'll use the add last, and we'll use the add all method of the list interface and the deck interface. So here is going to be the source code that I've embedded inside of the slide, but why don't we jump over to our IDE where we can actually run this and we can read it a little bit. So here we are doing a linked list tester. Let's open this up. So we're going to go ahead and import array list. We're going to import linked list. We're going to import vector. We're going to import, so we're going to import two different concrete lists, and then we're going to import our linked list. Okay, we're going to create our class. We'll call this linked list tester1. I'm going to create a main method here so I can actually create an application using these containers or collections. So the first thing I'm going to do is I'm just going to create an empty linked list. And now remember, a linked list is something we could normally do with generics. And normally you want to use generics, but also see that it's optional. So for this purposes of this initial example, we're not using generics. Here we will add a 1, right? We'll add a 2 because guess what? We didn't claim the type of data, so everything's just going to be treated as an object, which allows us to have mixed data types in there if we wanted to. Super dangerous, by the way, in production, always use generics, but just illustration, we could do that. So 1, 2, let's see here. We will go ahead and add a null, and then we will add 4. Okay, so our initial, and then we'll print out the initial linked list order. And then what we'll do is we'll do another add where we'll give the actual index and then the element we want to add, which is going to be 3. And then what we'll do is we're going to print out a message that says the linked list elements after adding the first element. And so we're going to call add first, and we're going to put 0 as the data. And then we're going to print out the list. Then we're going to print out a new message, linked list elements after adding the last element. We're going to add at the end of the list 5, the text 5. And then we're going to print out the state of our list. Then we're going to create a new array list. We're going to add into this array list a 6, the number 7, and then 8, the string 8. Then we're going to tell the list add all, and we're going to pass a collection, this new collection, AL, into the list. And since we're doing AL add all without the index value, it should add it to the end of the list. So then we'll put the linked list elements after adding all elements from the array list, print out a message, and then print out the state. Then what we'll do is we're going to illustrate that add all is, since it can be any collection type, we're going to make an entirely different type of collection. So before we had a linked list that we added to another linked list. Here we'll take a vector and make and add some values into it. So we'll add into vector 7.5 and 7.8. And then what we'll do is we'll add to our linked list at index 9 all of the values that are held inside the vector. And then what we'll do is we'll just print out the state of our list. Oh, and AL was an array list. I'm sorry if I didn't mention that. I got so used to looking at linked lists. So this is an example that we can take an array list and add that into our linked list. We could take a vector and add that into our linked list. We could take any collection and add that into our linked list. Let's go ahead and run this code. Let's run that. And if we go ahead and look, we see, yeah, our initial or linked list order was 0, then the number 2, then null, then 4. Then the linked list element after adding the first element, we have 0, 1, 2, null. And remember, we did this add 3 here, index 3, 3 here. We didn't print out the state after that. And then 4. Then we have linked list elements after adding the last element. So 0, 1, 2, null, 3, 4, and that's 5. That's adding to the last element. Linked list elements after adding all elements from array. So remember, we had this array with 2 null. Where was that? That was AL here. So we 6, 7, 8. So yep, 6, 7, 8. That came from the array list. And then finally, we were going to add in this vector 7.5 and 7.8, but we're going to do that at index 9. So that happened here, right, between the 7 and the 8. So notice the actual code for using a linked list looks exactly like an array list for the most part. And so that's going to be the expected output. And so how do we remove an element from a linked list? Well, let's take an example program where we'll use different ways. We'll use remove first, and remove last. So this will be the source code that we have for our remove. But let's go ahead and just open that up here. So here, I'm going to do the same thing. I'm going to go ahead and import an array list. I'm going to import a linked list, and then I'm going to create a class that I'm just going to call linked list tester 2, which is going to be a application class. So I'm going to have a main method. Here, I'll create a linked list, a new empty linked list. I'm going to use the generic, so it will hold strings. I will then go ahead and query the list for its initial size, and I'll print that out. And then we'll add some elements into the list, which all are going to be strings. We'll also add in a null reference just to illustrate that we are allowed to hold nulls in our linked list. And then what we'll do is we'll print out the state of our list after adding some elements. Then we'll do a remove first and then print out the state of our list. Then we'll remove the last element and print out the state of our list. Then we'll remove from a particular index and print out the state of our list. And then we'll create a new array list. We'll add 2 elements to it. We'll add those at index 2 to our list. And then what we'll do is we'll call the method remove last occurrence of this string that says 4, and then we'll print out the state of our list. Excellent. Let's go and run this. And if you have any questions about if I'm going through this too fast, just let me know, and I'll try to address those questions. Ask me inside the chat. And so now if we go ahead and look at the output, we see, yeah, the starting size is 0. The initial set of values is 0, first, second, null, fourth, and 25. After removing the first element, it becomes first, second, null, fourth, and 25. After removing the last element, it just becomes first, second, null, and fourth. And then the linked list after removing the element at index position 2 is going to, that's the null value, right? So 0, 1, 2 is at position 2. So it's going to become first, second, and fourth. And then the elements after removing the last occurrence, well, that's going to be first, second, third, and fourth. That looks the same, but it really isn't, because before we did that removal, we actually also added a fourth here. Right, we added a third and a fourth, and then we removed the last occurrence of fourth. So excellent. And so again, just a conceptual view of removing an element is like given here, which we've already covered, but I have these in the slides for you to be able to look over, and that's our expected output. And so How do we get an element from the linked list? Well, we have the methods get first and get last. So we're going to build a simple software here, a linked list tester 3. So again, let's go over here. Let's open up our linked list tester 3 and take a look at what this looks like. So here we're just going to go ahead and import linked list, right, from our java.util package. We're going to create a class definition. We'll create a main method so we can actually run some code and play around with this framework. Here, we're going to create a variable of data type linked list that holds integers. So we're going to go ahead and use that type parameter type. And then what we'll do is we'll go ahead and make a for loop since this is for integers. So we'll set I to 0 until I hits 20. We'll see if it's an even. If it's an even number, then we'll add it to our list. So this will be the collection of even numbers from 0 to 20. Then what we'll do is we'll get the first value and we'll print it. We'll get the last value and print it. Then we're going to get a value at a particular index and we'll print that. So let's go ahead and run that. And here we can see that the first even number is 0, the last even number is 20, and the even number at index 5 is 10. And this is our expected output that's pulled right from the IDE. And then how do we retrieve and remove elements in a linked list? Well, we can retrieve and remove an element from the linked list using peek first, peek last, pull first, and pull last. So peek first is the method that retrieves the first element from the list, but does not remove it. Peek last retrieves the last element from the list, but does not remove it. Pull first retrieves and removes the first element. So it mutates the state of our list. And pull last retrieves and removes the last element for the list. And the reason why we actually have these actions, these dangerous actions that have more than one role, more than one responsibility, it acts as both a query and a command. It acts as both a getter and a set, kind of a set as a remover, is because that's pretty critical for stacks and queues. Common methods you have in stacks and queues is to push and pop, which means you're getting the value, but when you're getting it, you're actually removing it. So just like a deck of cards, when you go to draw a card off of a deck of cards, you're not only getting a value, but that you're removing that value from the container of the deck that was there before. And so that's a critical concept to this data structure. So it's important to have methods that do that kind of dangerous thing of retrieving, of getting and removing a value simultaneously. Okay, so with that said, let's go ahead and have a actual working program that uses this method so you can see it in action. But instead of looking at it on a slide, let's actually look at it inside of an IDE where we can run the code, make sure it compiles. Here, we're going to import our linked list from the java.util package. We're going to create a class definition. We're going to create a main method so we can actually run this. We're going to create a new empty linked list to hold strings. We're going to add a lot of values into that. So India, USA, Japan, UK, Canada. And then here what we'll do is we will then print out the initial state of our list after adding those elements. Then what we'll do is we're going to do peek first to get the first element, and it's going to be then we'll go ahead and we'll print out the first element to illustrate that we retrieve that value, and then we're going to go ahead and peek last and do the same thing. We'll print that to illustrate that we retrieve that value, the last value. Then we'll do pull last and grab the value stored in memory. Then what we'll do is we're going to print out the value we stored, but also the state of our list after pulling the last element from it. And so if we run this, you can see here our initial order is India, USA, Japan, UK, and Canada of our linked list. We can retrieve the first value is India. We can retrieve the last value, that's Canada. We can retrieve and remove the last value, that's Canada. So now when we look at this new state of our linked list, we could see that last method of pull last not only allowed us to capture that value inside of the variable here at element 1, but now when we inspect list, it's been entirely removed. And that's just the expected output. And then what we're going to do is we're going to do pop and push an element from and onto the stack in our linked list using the pop and push method. And so here, let's go to the source code. So that's going to be linked list tester 5. Here, I'm just going to import linked list. I'm going to create my class. I'm going to create a main method. I'm going to create an empty linked list of data type character. We're going to add some chars, A, B, C, D, and E. We're going to print out the initial state. Then we're going to pop, which is going to return the last element on there, and then we're going to print that out, and then we're going to push onto there the value B, and then we're going to print out the new state of our list. So if I run this, you can see what's going to happen is we added A, B, C, D, E. Yep, that's all in our linked list. We're going to pop our element A. So we're going to pop the head of the last thing. So A, B, C, D, E. Yeah, we're going to pop the value at the head of A, and then we're going to push onto the stack B. So the way that linked list is modeling our stack here is that the head represents the top. And so the bottom is going to represent the very last thing. So again, adding, and so a big indication here then is knowing that the first element represents the top is adding puts things in sequential order. Push and pop puts it in a particular order. So since the push is putting everything at the top, yeah, your pop is going to remove the first element. And so, and not necessarily, so if you want to use this as a stack, you can also remove this as push. You do all your pushes here, and then that'll push it in a way that will keep the ordering the way you'd want. But let's not do that. Okay, let's save that. And yeah, that's going to be the expected output. Excellent. And so there's one more. That's it for our code examples. And I think likely what I want to do is move on from this section